Async Profiler is a small, fast, and very effective Java profiler. Let's see how to use it locally and in containers. Async Profiler is an open-source, low-overhead Java profiler for JVM-based applications. It is really small and comes without a graphic user interface. Thanks to that, it can be embedded into other systems, and its work is almost invisible to the application and has almost no impact on performance. What distinguishes it from other profilers is that it doesn't suffer from the Safepoint-biased problem. Yeah, but what is that? You see, Java threads mutate the heap, but the JVM sometimes needs all these threads to stop so that it can perform internal work safely. A safe point is the moment in time when the JVM knows exactly that a thread is in a well-understood state. Only in this case can the JVM safely pause this thread to inspect or do some other internal work. For example, it is needed for stop-the-world garbage collection process or for stack sampling. So what is a safe point bias then? Safe point means that the profiler samples only at JVM-approved safe points, not at some random point in time. So, instead of seeing where the CPU is spending time, you may see where the program was when it reached the safe point. Okay, I know it may sound too vague, but let's imagine a situation. Suppose you have some very hot code inside a tight loop. But if there's no safe point inside this loop, the profiler might be unable to sample the thread when it was doing the expensive work. Then the code finally reaches the safe point near some, cheap method, for example, or a method return. So the profiler report may say that this cheap method is to blame, but in fact, the expensive work was in the loop before it. As a result, a safe point-biased profiler may send you optimizing the wrong method. So, ideally, you should use profilers that avoid or minimize the safe point bias. For example, Async Profiler. It is also useful to add the debug non-safe points JVM options because the Async Profiler or other safe point profilers may, even in this case, profile more accurately. Okay, so Async Profiler doesn't suffer from the safe point bias problem. What else can it do? Async Profiler can collect data on various JVM events, CPU usage, heap allocation, methods, and so on. Plus, it can monitor non-Java threads, native calls, and kernel functions. You see, it's really powerful. What is more, setting up this profiler is really easy. Download the latest stable release from the project's GitHub repo. The builds are available for Linux and macOS only. Unpack the archive. There you will see two directories. The lib directory contains the profiler library that can be attached to the app as the Java agent. The bin directory contains the asprof tool that attaches to the running JVM process. Okay, let's first look at how we can attach to the running Java application. First, start any Java app. The docs state that it is recommended to start the application with 2 additional flags, debug non-safe points, and unlock diagnostic VM options for more accurate profiling. We have already discussed that. In the simplest possible scenario, you just need the PID of your process, and then you can simply run asprof start with PID. Afterwards, you can stop the profiling at any point in time with a similar command, asprof stop and the PID. After that, you will get the profiling results as the console output. But of course, you can specify additional options. For example, you can set the duration of the profiling, the output format, the JFR file or the Flamegraph, or the event that you want to profile. The full list of possible options is, of course, in the docs. You can also attach Async Profiler as an agent at application start, and the profiling will start right away with application start. This way, you can get valuable information about the application behavior when it starts. You can add the profiler manually, or you can use Alpaquita Linux as your base image, and in this case, adding the Async Profiler is just a matter of adding the package from the repository. If you want the profiling to start with the application start, you need to specify the profiling options and attach the Async Profiler in the entry point. Otherwise, leave the entry point as is. Okay, build the container image. Now we need to configure the Linux kernel to allow access to the performance events. For that purpose, you need to set the perf event paranoid to 1 and kernel kptr restrict to 0. These options are available on Linux only, but as you are probably running your production containers on Linux, then you're good to go. Another important notice. Docker containers by default restrict the access to perf event open syscall. So to profile the app with Async Profiler, you can use one of the following approaches. First, you can add the capability sysadmin to access the privileged performance event information. Secondly, you can disable the default security computing mode profile. For that, you can use security opt secomp unconfined option. Thirdly, you can use FD transfer option with running the container as a privileged user. And finally, you can fall back to the C-timer profiling mode. It is similar to CPU mode, but it doesn't require the perf events support. So the command for running the Docker container may look like this. You specify the system admin capability and you disable the default security profile. Okay, the container has started. And if you attach the Async Profiler as an agent at application startup, the profiling has already also started. Now, how do we retrieve the profiling data? The profile HTML file will be created automatically in the tmp subdirectory when you stop the container. But what if you don't want to stop the container running in production to retrieve the profiling information? In this case, if your container image comes with a shell, you can async into it, or if it doesn't contain a shell, you can attach the ephemeral container to it. In either case, you need to enter the container. Okay, in our case, we had the container image with shell, so we just ran docker exec, and we are inside the container. Now, as we have installed the Async Profiler package, it includes the asprof tool. It can be used to stop the profiling, to resume it, or to dump the profiling data without stopping the container, and also without stopping the profiling. Okay, let's find out the PID of the Java process running in the container, and after that you can simply use asprof to dump the profiling data to the file. And after that you can simply copy the file to the current directory with docker cp. This approach can be used for interactive profiling as well. So suppose you added the Async Profiler package, but you didn't start the profiling at application start. You can start it or stop it at an arbitrary point in time using the same approach. So you can async into the container and use asprof to start the profiling session. And that was a quick intro to Async Profiler. The article with the copy and paste examples of the code is in the description. Don't forget to like this video, subscribe to our channel, and until next time!